Everyone, good evening. My name is Karan Chaube, and I am about to show you how I did my work of data science for the internship of Exposys Data Labs. So we have the data set ready here, that is comma separated values. Okay. This is our data set in which we have 5 columns. One is customer ID, gender, age, annual income, and other is spending score. So we will performing unsupervised learning models over them. So we'll be using Anaconda Jupyter Notebook. Let's create a new file and we'll get started right away. First, let's import pandas as PD. Then we will read the CSV file that is and store it in a DF data frame. Okay, so PD dot read underscore CSV, and we will pass the path here. So the path is yeah, and name and put the name of file customers dot CSV. Okay, so our data set will look like this. Before we perform our unsupervised learning models over this data, we have to first process the data. That is, we really don't need the customer ID because it is just the numbering of the data columns, data rows, and the gender is in string format. We cannot perform mathematical calculations over it. And see these names of the column, that is annual income, that is K dollars in, and spending score from 1 to 100. We need to rename them so it will be easier for us to code and it will increase our speed. So let's do these things first. Let's drop df equals to df dot drop customer ID and access equals 1. Okay, so we have dropped the customer ID. Now we have to rename annual income and spending score. So it's a df equals to df dot rename columns equals annual. Okay, now we are missing something here. Annual and this annual income, that is K dollars, and we want to replace it with, let's say, A/I. So it will be easier for us to understand. And in place equals true. Same thing we want to do with the spending score. So we will be just spending score, that is 1 to 100, and we want to name them S/S. Okay, what happened? The none type had no attribute rename. Happened. Let's see first. Okay. Okay, we just don't need to do this. So S/S, and we don't need to do this. Now what happened? I know this is the right way. Something is wrong. Something is wrong. Now it is happening. Annual. And now we want to do the same thing with the spending score. Spending score, that is starting from 1 to 100, and we want to name it S/S. Now it will be easier for us to understand and do the coding etc. stuff. So the data frame will look like this. Okay, it is much cleaner. We have to first change the gender column so that we don't need we need the we don't need the string values. Instead, we need the numerical values to perform our calculations. So we will doing gender mapping. We need to convert the male values into some stuff like taking 0 for male and 1 for female. So we'll be doing for female we will be using 1. Okay. Now df dot gender, the name of the column is gender, so df dot gender equals df dot gender dot map, to map the values accordingly. Okay. And we'll pass the parameter of gender mapping. So it will replace the values of male with 0 and females with 1. Okay. So now our data set will look like this. See, it is happening now. For performing our unsupervised learning, we need to convert these values in the range of -1 to 1 as in order to know which column is interrelated to other column and which column is correlated to each other. So we have a better understanding of the values because they all will be ranging from -1 to +1. Okay, so let's do this. For age, firstly, age is equals df dot age. Min value that we need is minimum of ages, that is actually df dot age, and max value is max ages. Okay. Now minimum range that we need is -1, and the max range that we need is +1. Okay. Now df dot age equals we have to convert this. We have to apply a formula that is it is quite tricky to know. Actually, I generally apply the um, logic instead of using function sometimes. Minus minimum value divided by max value minus minimum value into max range. I guess that's the formula. Yeah. Plus into max range minus max range minus minimum range plus minimum range. That's our formula. So let's perform this operation. I hope it works. Yeah. Now let's see. Okay, the age column has been converted into the all the values are now ranging from -1 to 1. Now doing the same for other columns. That is just, let's copy it, and for AI, that is annual income A/I, doing the same. Let's just copy and paste, and this will help in decreasing our typing. Let's see. Okay, this has happened with annual income too. And now for the spending score. For spending score, that is S/S, S/S, S/S. Okay. Now the data set will now look like this, and now this data is ready for performing our unsupervised learning models. So in the beginning, we will be applying the k-means clustering. Okay, so we will be importing from sklearn sklearn.cluster import k-means, and it will not only enough. We have to scale the values. So we will be applying sklearn dot preprocessing import min max scalar. Okay, just don't create an error. Okay, so first we will scale the values. So let's put this min max scalar into a what we say, a variable named scalar, that is min max scalar. We have put it in this. Now scaled values equal to, let's say, scaled data instead of scaled values. Scalar dot fit transform, and our data set is df. So let's do this. Okay, now to perform k-means, we know that we have to first find out the number of k's by elbow method. So before performing k-means clustering, we need to know the number of k's that we have to find out. That is within the cluster sum of squares. That is, let's put this within cluster sum of squares, WCSS, and taking it as an empty list or array. K values that will be ranging from 1 to 11. And now for k in k values, k means equals k means and cluster equal to k, and k means dot fit. Now we will be using this scaled data. This is scaled data here. Scaled data. Now, and every value will be appended to this empty list. That will help us. WCSS dot append k means dot inertia. Now let's do the calculations. Okay, just don't create an error. Okay, so it will not show us the result unless we plot it. So let's import matplotlib.pyplot as plt. Okay, importing. Now let's plot it. So plt.plot k values on the other side, that is x-axis, and the values we appended on WCSS will be on the y-axis, and we will be taking the marker as O marker. Okay, let's see. Okay, k values. Okay, the k is capital here, typo. Okay, so this is not looking very good without the label. So let's do the labeling too. plt.x label, that is number of clusters, that is k, and plt.y label is the WCS, that is within cluster sum of squares, that is WCSS. Okay, plt dot title, putting a title over it, that is elbow method. Okay, plt dot show. Now it is looking good. So we are seeing we have two elbows here, so we'll be taking 3. So now we'll be applying the k-means clustering. So it will be like we will take k-means n cluster. We have found the number of clusters that we need, that is 3, and k-means dot, and we'll pass our data set. Now cluster labels, we have to define the cluster labels, and like which cluster is in which values is falling in which cluster. K-means dot labels, that is provided by the k-means. Okay, the cluster centers. Okay, cluster centers, in the centers of the cluster, scalar dot inverse transform k-means MENS means dot cluster centers, TERS. Okay, now we have to add a new column that is named after the clusters, that is clusters. Which cluster actually? So it will be cluster labels. Now we have to assign the values. df equals df dot assign, and what to assign, that is cluster equals cluster labels. Now what? Got an unexpected argument and clusters. And clusters. What went wrong? See, okay, this typo, clusters. Okay, so we have performed our k-means clustering, and now we can see that the which value belongs to which cluster. That is, gender belongs to cluster 1, age belongs to cluster 1, and this gender female belongs to cluster 2. So now we have to plot whatever we have did. Now plt dot scatter df dot cluster. We will be using df dot cluster in the x-axis, and we will be plotting. First, let's take spending score. We will be taking spending score in the beginning. Okay, so all right, is not looking good. So we will be labeling the x label, that is clusters, and plt dot y label, and that is spending score. Spending score. The title should be k-means. Now it looks good. So here we see that the cluster 0 is having values from range -1 to 0.25 in spending score. The cluster 1 is basically having the values from starting from -0.25 till value 1. And here in cluster 2, basically 3 clusters, 0, 1, and 2. We have plotted this. Now doing the same with other columns too. And this time we will be taking age. Let's take age. Okay. So we see in cluster 1, there is no one from the age varying from 0 to value 1. So, and doing the same with other clusters, that is, let's take annual income now. A/I /I. Okay, we have plotted this one too. And for the same, we do for gender now. Done. So here we see in cluster 0, there are no females, and in cluster 2, there are no male. And in cluster 1, there are both male and female. Okay, moving on. We have done the k-means. So now we will be doing DBSCAN. We will be applying DBSCAN clustering. Okay, so importing the libraries from sklearn, learn dot cluster, import DBSCAN. And for this, we will be using standard scalar instead of min-max scalar. So importing that to sklearn dot preprocessing import standard scalar. Okay. So let's look at our data set. Now we don't need this cluster for DBSCAN. So we will be dropping this df equals to df dot drop cluster and axis equals 1. Okay, so data set should look like now this. All right. So now to perform DBSCAN, we first store it in a variable named DBSCAN. So DBSCAN, DBSCAN, and there should be EPS should be 0.5 and minimum sample should be 5. Okay. So clusters equals to DBSCAN dot predict df. Okay, so it has done. Now we will be adding a new column named clusters. Again, cluster. Now this clusters this cluster belongs to DBSCAN, not to other k-means. So cluster, sorry. Now let's see how. Okay, so it has created some clusters 0, -1, and 1. Okay, now we'll plot this DBSCAN plt dot scatter df, which column we want to we'll be plotting. Let's take spending score with annual income. Annual income, and the C should be clusters, cluster, and C map we will be using VDS. Okay, let's see the plot. What happened now? Oh, what's the error? Let me see. Value error. plt.scatter. Let's see what is wrong here. Uh, Viridis. Okay, Viridis. Sorry, we had a typo. So this is the let's label it. This is not looking really good. So plt.x label, that is pending score, and plt.y label is annual income. Okay. And plt.title is DBSCAN cluster. DBSCAN clustering. Okay, plt.show. Now it looks good. Now we will be applying same thing over other columns. That is, now we will be taking age now instead of uh, annual income. Let's see what happens. Okay, so we have the graph of spending score, spending score with age, and we already have done annual income with spending score. Now the remaining column should be like we have to do the gender. Okay, so we will be taking gender and gender. Okay, so we have the clustering for DBSCAN in gender and what columns are now remaining? We have to think gender and age. The gender and age is remaining. So gender and age. Okay, we have plotted this graph too, and now gender and annual income is remaining. Gender and annual income. Okay, this is done too. Now which one is remaining? Annual income with age. Annual income with age. So we have plotted this too. So we have plotted all the columns in the clustering of DBSCAN. Now moving on to what should we apply now? The Gaussian mixture model. Gaussian mixture model. So we will be taking a Gaussian mixture model from sklearn dot mixture, import Gaussian mixture. Okay, so we already know that we will be taking two clusters in Gaussian mixture model, because the steepest elbow we found was at 2. So we will be taking clusters equals to 2 clusters, and let's take a Gaussian mixture model into a smaller form, that is GMM, in Gaussian mixture, and the components will be using n components equals to clusters. Wait, we have to first remove the cluster column, this clusters df dot df equals to df dot drop clusters x is equals to 1. Now our df should look like, okay, df is back in the form. Now gmm dot fit df. Okay, so n components that we used to. Now we will be plotting labels equal to gmm dot predict df. Okay, we have done the thing that we needed to do. Now we'll be plotting capital df dot gender. Let's take gender and df dot with gender we should go for, let's say, spending score. C equals labels. This labels and C map should be, again, let's take viridis. Now this time I'm not going to do the same mistake. Viridis. Okay, I always forgot to label them. X label, that is gender. Y label is spending score, and title should be Gaussian mixture model. Clustering. Tilde dot, we should use color bar to understand which color bar goes for what. Color bar. Okay, color 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 bar TLT dot show. Now this looks good. This is the gender, that is 0 for male, 1 for females, and this is the spending score. Well, spending score of females are higher than the male because we see it is quite steeper than the females. Okay, going for the other ones, other columns. TLT dot scatter. Now we should be taking gender and let's take annual income now. Annual income. Okay, annual income. Okay, we have plotted the graph of annual income and gender. Now we will be taking age. Age. Again, we have done with the age. Now for going for other columns, that is age with annual income /I. Annual income, and this is age. Right. We have plotted this too, and remaining columns are, I guess, age with spending score. Taking this with spending score S/S. Okay, we are done with this too, and the one are remaining, that is spending score with annual income. pending store with annual income. So, okay, what happened? Okay. Now, we have plotted all the graphs of every column with each other for a Gaussian mixture model, and going forward, moving further with which one should we apply now? That is, we should be applying principal component analysis. Principal component analysis. Okay, so importing this from sklearn dot decomposition. Decomposition will be importing PCA, principal component analysis. Okay, so well, excuse me, looking at our DF. So excuse me. Let's move on to PCA. That is taking PCA into a smaller name to call. So n components. That is as we took in Gaussian mixture model, that were 2, and principal components, that is PCA dot fit transform DF. Now it will do its job. Now principal data frame, that will be using PDF principal data frame. It will be creating its own data frame. So PD dot data frame. Okay, so data equals principal components columns. That will be what we should name them, that is PC1 principal component 1, and the other one should be principal component 2. Okay, so these will be two principal components that we have taken n components to of principal component analysis. So there will be two components, and the data frame, it will create a new data frame consisting of two columns, and there will be two components of every rows, two major components. So taking this, and let's see how PDF looks like. See, now let's plot this. So for the better understanding of the data scientists, so plt dot scatter PDF, taking in the x-axis, PC1 in the x-axis, and PDF dot PC2 in the y-axis. This time I'm not gonna forget about the labeling. X label principal component 1 plt dot y label principal component 2. Okay, and the title should plt dot title should be principal component analysis. Okay, graph plt dot show. Go for it. Okay, so we have this principal component 1 ranging from value -1 to uh, -1 to 1.5, and here we have the principal component 2, which is valuing from -0.8 to positive 0.8, and we see two clusters over here. That is, there is no one in the no one clashing when the principal component value is 0, and we see a very little people in the if we draw the straight line, there is no one in this intersection. So it will be easier for the data scientists to understand. Now we will be applying Which one is left? Let's see. The T-SNE. All right, the T-SNE is remaining. That's a unsupervised learning model. You have to apply T-SNE. Okay, so importing it from sklearn dot manifold. It will be found in manifold and import T-SNE. Okay, now to perform T-SNE, we have to, let's take features as a uh, the as the variable that we want to take. Let's take four major columns. That we have only four major columns, so we will be taking data df.iloc. Using this function, we will be able to take from beginning to end values of our columns, and taking the columns, four columns. We have major four columns, that is age, gender, annual income, and spending score. So what happened? Okay. Oh, okay. This goes with this. We have chosen wrong brackets. That's why it is showing some error. And let's take T-SNE in a smaller form to better understand our program. So n components, again, we will be taking two major components and embedded features. Let's say embedded features T-SNE dot fit transform our data, that is features. Okay, we have taken the data in such form, so we passing features here instead of df. Now it has done its work. Now we'll be plotting the graph. Scatter embedded. We'll be passing this in the x-axis. Embedded features, and we'll be taking from beginning to the end, and we'll be taking interval 0 and embedded features embedded features, and we'll be taking this time from beginning to the end, and the interval should be 1. Again, labeling it x label T-SNE component 1, and utility.y label T-SNE component 2. Okay, now titling this utility.title. This should be T-SNE I'm facing a hard time with this new keyboard. Visualization. T-SNE visualization. Okay. Same mistake again and again. TLT dot show. Now let's see how the graph looks. Okay, there are two clusters of two components, and this values component 1 value is ranging from -10 to +10, and T-SNE component. Okay, we have done something here. So now it looks good. T-SNE component 2 range starts from -10 to +15, and it is ranging more than the component 1. And we see the major number of values are falling in this area, that is ranging T-SNE component 1 -0 to 5, and in this we see this might go -15 till, I guess, if we draw the straight line here, so we might find -2 or 3, -2 basically, technically 2 or 1. Okay, so we have done T-SNE, and by this we have covered 5, like first, second, and third, and fourth, and lastly fifth. We have done 5 unsupervised learning models, and we are good to go. We have completed the project of applying 5 unsupervised learning model over this data set. So now we are good to go. Thank you.